Hello and welcome to your first day of Contemporary World Cultures. Today we're going to talk about how geographers see the world. This is actually Unit 1, Chapter 1, Lesson 3 in your book. All right, so the objectives today, I will start to think like a geographer. Now, if you've never done any of these, today I will, so I will know I haven't win before. It's a good way to kind of think about what are we going to do today in class and what are we going to learn. So it's a good idea to kind of repeat it after me or say it along with me in your own room. So let's try saying it together. Today, I will start to think like a geographer so I can deepen my understanding of the world. This prepares me for future topics in the course and others. And also so I can understand why some people live differently than I do. And that's the big one. That's kind of the whole point of the whole class. I will know I have it when I can tell my friends and family how geography helps you understand places and the people who live there. So what this means is that, if somebody asks you, what did you learn at school today? Now you have something to tell them, right? You can tell them how people and places, or how places affect how people live, actually. Okay, so what are we going to learn? Well, we are going to learn about geography. What is geography? So, what is it? Well, it's the study of the lands, features, inhabitants, and phenomena of the Earth and planets. So in other words, we could talk about geography of other planets, like geography of Mars, or geography of the moon, or an asteroid. That's one thing. We're not going to do that in this class, obviously. We're going to talk about Earth. And the other thing is, so if you ever see like logi, like biology, that's a little bit different than this, as we have graphy here. But the logi means study of, so it's similar. I think it comes from Latin. And we have geo right here, which actually means like dirt or earth. And then we have graphy, which it comes from graph, which is a way of showing something. So the word gives you clues about what it means. All right, now we have a video about the Mercator map projection. So let's go ahead and watch that.
In the early 16th century, navigating at sea was a perilous business. Ships crossing the Atlantic could find themselves hundreds of miles off course, with deadly consequences: starvation, dehydration, shipwreck. And maps were the problem. Due to the curvature of the Earth, ships trying to follow a straight line on a map ended up veering dangerously off course. But in the mid-16th century, there was a map-making revolution. It would solve this navigational problem and inspire the creation of the most influential map in history. It still defines our vision of the world in the 21st century. After studying mathematics, geography, and astronomy, Mercator began making globes for European royalty and other wealthy patrons. To do this, he outlined the countries of the world onto a series of long segments of paper called gauze. When joined together, they would fit perfectly around a globe.
This globe is made in 1541 by Mercator.
It's beautiful. It's absolutely exquisite. So how would you make a globe like this?
When you make a globe like this, you had to put on plaster, and then you had to put on it the gores who were engraved on copper. To make a gore has to be very accurate. But what's amazing is the stream continues on the other sheet.
I can't see the joins here on the gauze. It's done with incredible skill.
Building on his work as a globe maker, in 1569, Mercator devised a new method of projection onto a flat surface to help navigators at sea. Mercator began by straightening the lines of longitude, or meridians. He then increased the spaces between the lines of latitude, moving away from the equator.
Here is the famous world map from Mercator. He made this map in 1569, a new map for sailors in his time.
For the first time, navigators would be able to plot a straight line between 2 points on a map and safely reach their destination. To achieve this, Mercator had struck a cartographic compromise. To ensure navigational accuracy, his projection increasingly distorts the size of countries the further they are from the equator.
They're actually mapped to infinity. I mean, they're vast. And it's the same down here.
On the pole, yeah.
So the South Pole goes like this.
Goes like that.
So it's a way of stretching.
Stretching the world.
But as a result, you do get this massive distortion.
Mercator distorts the globe in other ways too. By deliberately placing the equator south of the center, he gives Europe a dominant position in the world.
So we learned about the Mercator map. And basically what they were saying was that a long time ago, they didn't have maps like we do today. Right now, you can open up your phone, go on a computer, and you can find any map of anywhere in the whole world, and you can zoom in and see really good detail. In fact, you can even touch something and see pictures of it and people's reviews and comments. It's really amazing the kind of technology we have today. And you could see the globe that they created. That was how people could perceive the world. Nowadays, we have pictures of the Earth from space that we can look at. So it's really special, the kind of technology that we have, the kind of knowledge and information we can get from the world that we have today. So back then, this guy had the first idea to be like, oh, okay, well, we're going to take this round thing and we're going to put it on a flat thing. And if you've ever tried like to peel an orange by hand, you know that it's round, but then you take the orange and you try to smash it onto a table, it doesn't quite work. The orange kind of gets all ripped up and it's still kind of curvy and things. So that's really the kind of challenge that he was facing. And the way that he decided to do it was stretch out kind of the upper parts of the globe, because as you go up on the globe, it gets smaller, right? So when you cut it open, you have to stretch that so that it will fit out into a piece of paper. So that's what happened. Okay, and so at this time, if there are any words, if you have any questions about anything, please ask your teacher. Make sure you raise your hand, push the button in Zoom to raise your hand. Oops. Okay, all right, next. What geographical features would be important to you in choosing a new place to live? So you have to think about people a long time ago, okay? Very, very long time ago. So like there's nothing, there's no cities or anything. You're just walking in the grassland. There's all kinds of grass around you. Where do you stop? Why do you stop? Why do you choose to sleep in any given area? So let's talk about that. And I want you guys to do a pair, or like what we call a breakout room for 2 minutes. And your teacher will set that up now. Then I want you to come back and share what you talked about with your partner in the chat box, okay? All right, so based on what you talked about, and I'm just going to guess since I don't know right now, but some important things would be like water, okay? So if you wanna, a good place to stop is some places close to water, because you need to drink to live, right? You need to eat to live. So a place where you can either grow food or you can find food. Maybe there's some fruit trees, you're gonna stay there for a while. There are some berries or something, you're gonna stay there. Or maybe there's lots of animals that you can go hunt. So that's where early people made their homes. And those homes became not just one person, but families, and families had more families, and then communities build, and then we have tribes, we have you know, countries that eventually start to form. And so within that, any city, for example, well, like New York City is on the edge of America. So there's lots of water there. So whenever they came from Europe, they just stopped. And it was a place with lots of water, and it's a really big river where it's easy to go up and down. And there's also, at the time, especially even in New York City, where New York City is today, they had a lot of deer. And so they could kill the deer and eat the deer. And so that's where a community started. And then eventually they had lots of trade, lots of boats came there. And so people came to sell their things and to sell. If you're a person who sells something, you work at a store, well, you need to have somebody to cook your food for you, go hunting for you. You need to have somebody to make other products or the products that you're going to sell. So eventually you have this whole community and city and then eventually country that develops in a whole new part of the world, okay? And then, why would these features be appealing or necessary? And we just talked about that because it's for life. You have to have them to live, okay? So that's another reason why you won't see very old cities in like a desert or in a place without water or food, because like, for example, the 1960s, I think, is when we saw lots of people moving out west. So to like, especially New Mexico and Arizona, because of the invention of air conditioning. It was just too hot. And plenty of people lived there thousands of years ago, don't get me wrong, but in terms of modern times, we saw most people starting to move there when it became easier to live as a result of the development of air conditioning. So, all right. So then again, we're going to talk about that in the chat box if you haven't already. All right. Next, what might geographers learn about other communities from studying the effects, for example, of Hurricane Katrina over time? So maybe you don't know about it. I think it was back in 2005. There was a huge hurricane that came through New Orleans and Louisiana, right next to Texas. And this is just a picture. So you can imagine how this community would have looked before the hurricane came in, right? Before we have all these lots and lots of rain, lots of wind and all that stuff. Why do you think that there are so many coolers and tires and other debris right here? Why is that here? You can just think about it. Well, it's because you have lots of water that fell, right? Or, from the sky and rain. And then that makes almost like a little lake because the water can't go anywhere, right? And when it does that, it kind of mixes around in people's houses, pulls all that stuff out, and there it is in the water, okay? So it messes up the entire community. They had a huge, huge problem to get people out of there and obviously also to clean up. And then you can see in this one here is potentially what a house looked like after, because it was kind of overtaken by nature and it wasn't feasible to go back and live there again. So they just let nature take over. So think about that. What can we learn then? If we have this happen with this big flood, would we want to live there again? Well, no, this person didn't. These people decided, okay, well, what if that happens again? I don't want to live there, right? So that changed a community, and that's nature changing us, because nature is, and we can't do anything about it because it's just natural. All right, so the next thing is a couple of other examples around the world. So stuff that happened like a long time ago. For example, here, I'm just gonna read this. I'm not sure how to pronounce this word, but it looks like a Sateg Island is a barrier island along the coast of Maryland and Virginia. The constant pounding of waves changes the shape of barrier islands over time. So in other words, this happens a lot in Hawaii as well, for example, because Hawaii is a relatively new island and it's relatively soft material, but the waves are so strong and it hits the side of the wave. And so you can see these kind of half volcanoes a lot of times in the oceans. And this same kind of thing here, you can imagine how the land may have extended out further, but the waves just they were so strong and they keep going at it and going at it. And over thousands of years, they pull some of that dirt into the ocean and making the ground flatter and flatter and lower. Same thing here. The reason why these are sticking up like here, and by the way, this is in Australia, I've been here, but it's because this rock is harder. And there was more rock here, but it either kind of like melted somehow with the water. It dissolved into the water, and then that made the rocks kind of fall down and then go into the ocean and then be taken away out into, this is actually the kind of like the Antarctic Ocean, all the way out in, into the deep depths of the water. They actually call this I think it's called the Seven Apostles or something like that. And if you count them, there's not seven, because they fell over, and so they, even still today, this may have had, most of this falling and dissolving happened thousands of years ago, but it still is going on right now. So, every time you go back to look at a piece of rock, especially when it's in the ocean, it's going to look different. Okay. So keep going. Third one. This housing development shows suburban sprawl into a previously undeveloped area. So this is an interesting problem. In fact, Roy J. Smith Middle, which apparently you're not at right now, but if you look, even I'm just looking out the window right now, you can see how these new houses have kind of spread, and Killeen has really, really grown over the last probably 10 or 20 years, especially. So you can see here how this part, there's lots of grass, and you can imagine that in this area there was grass too before, or maybe even trees a long time ago. And lots of animals could live here, but now other animals, humans, came in and are living here. And so it becomes more and more difficult for nature to survive, because we try our best anyway to hold back nature. And you can also think about what happens when we build a city here, right? We're not going to have that nature anymore. It's going to be gone. It's not going to come back. We can't bring it back to be the same way it was. It's been like this forever, for as long as we can conceive as humans, but it's never going to be like that again if we start to build cities and towns there. So we have to be careful with what we do in our world. All right, the next one, this is another man-made, human-made thing in Egypt. So Cleopatras Needle is an ancient Egyptian obelisk that was moved to New York City Central Park in 1880. The photo on the left shows the obelisk in 1881. Obviously, we don't have a picture of what it looked like when it was new, but kind of a more recent one. This is like probably about 100 years later. On the right, note that weather and pollution have had harmful effects on the stone surface of Cleopatra's Needle. It's kind of hard to tell, but it's a little bit dirtier here, kind of more dark. Okay. So geography can help us predict what a house or a city, park, state, whatever, would look like in the future. So you can see that if there's lots of water that comes in when it rains, well, what if it rains a whole lot, right? Then it's going to flood, and maybe we don't want to live there. Maybe we don't want to build a house, or in reality, I mean, you don't want to buy a house if it's in an area with lots of water, because that water can very easily come into the house and destroy everything in it. So you need to think about that every day. I mean, humans, geographers, people, architects, whatever, plan based on geography. It also can tell us, and this is geography, about things like what kinds of food people might eat, or what kinds of sports might be popular. So Canada's famous for liking hockey. Well, it's played on ice, and it's a cold country, right? About food, places where it naturally, thousands of years ago, rice grew, people started eating rice. Places where naturally potatoes start to grow, well, that's how people ate most of the things. Same thing with like wheat to make bread. So these are very important parts of people's diet in their culture. Corn is another one. All right, show places on Google Earth. So let's take a look at that. Let's see here. Oops, wrong side. Yep, there we go. Google Earth. So if you never use this, it's really cool. You just type in Google Earth, and it basically has like a picture of the Earth. What they've done is they've actually taken a picture of every part of the Earth from space. And let's see here. So I just want to look at a couple stuff. So obviously this is the US, it's North America. And if we zoom in, you can still see lots of nature. At least it appears to be lots of nature. Kind of see where right in here. I guess we'll zoom in there first. This is Texas, right? And we're kind of in central Texas. There we go. It's populating. Oh, you can see our little bunch of concrete where Killeen is. You start to see the roads come alive. And we're going to go here. We're going to southern Killeen. It might be old images, I'm not sure. So there's the airport. And there's all the houses. Okay. So our school, see there's Walmart. I think our school should be right here. Oh, maybe it's there. No. Yeah, I think this is old. Roy J. Smith Middle School. So you can see how this used to be a field, actually. That's kind of cool, right? So this is where the school is now, but these are old pictures. So you can already see how our Earth has changed right here, okay? And we could actually go to Google Maps. So Google Maps is going to be more up to date, and it's already zoomed in here for us. And so if you push on this satellite pictures, it'll give you the satellite. So yeah, so now you can compare it. And so that's, the field is gone, and that field is not coming back. It would take a lot of work to bring the field back, right? So there's our school. All right, let's go to somewhere else. Let's type in Disney World, Orlando, Florida. Has anyone ever been there? You can raise your hand in the chat if you've ever been there. Walt Disney World Resort. All right, so what we want to look at here is kind of how they developed Walt Disney World. So you can see lots of roads. You can also see lots of trees. Now, some of these trees might be planted by humans. You can see how, you know, the parks, the different parks, so there's Epcot, Magic Kingdom, Animal Kingdom. So they're not like, you know, you can kind of see how they are next to each other. You might not be able to realize that if you actually go, but they are very close and separated by trees and probably fences too. Oh, and there's the airport. All right. So if there are any other places you want to look at, if you have extra time, maybe your teacher will show you now, okay? Or you can take a look at it if you're doing it on your own. Okay, now we're going to watch some videos about directions.
Hello, my name is Matthew. At school, my class is learning about cardinal directions. We use a map that shows north, south, west, and east. The map also has a compass rose that shows the directions. My class knows the directions on a map well because we use the compass rose, but we are having trouble remembering our directions when we are outside away from our map. So our teacher assigned a cool activity to help us remember. First, we drew a school in the middle of a large piece of construction paper. Then we drew a compass rose in the right-hand corner. Next, we drew the symbols for north, south, west, and east on the edges of the paper. Now for the fun part. We had to take a picture of something north of the school, something south of the school, something west of the school, and something east of the school. Now I have a hint before I show you my pictures. To me, north and south are a little confusing. On a map, north looks like it points up, so when I went outside, I thought north was up in the sky, and I thought south was down on the ground. But my teacher told me that that was not correct. Looking up at the sky or down at the ground is called up and down, not north and south. My parents helped me select my photos. I took a picture of my grandpa and grandma's farm, which is north of my school. I love tubing on the Missouri River, which is south of my school, so I took a photo there. My favorite park is west of my school. It has a very cool slide. The pool is east of my school, which I love in the summer. Then I printed small photos and glued them on my map. I also drew roads and other places around town. Now, whenever I'm trying to figure out which way is north, south, east, or west, I think about the map I made and the different photos. Thinking about the photos on the map and where the places are for my school helps me figure out my directions. With the help of a grown-up, you should try this activity. Take some photos, make a map, and have fun.
Hey Brain Stuff, I'm Jonathan Strickland. So you've probably seen geographic coordinates like these before, maybe on a GPS device or maybe scrawled in a mysterious note you found in the glove box of a rental car. But if you never knew exactly what they meant, fear not. It's actually pretty simple, and we are here to make it all clear. When you see a set of geographic coordinates looking like this, or like this, You're reading latitude and longitude. Latitude represents north-south location, and longitude represents east-west location, usually listed in that order. By combining them, you can pinpoint any spot on the surface of the Earth. These coordinates aren't expressed in units of distance, but in degrees. Why? Because the Earth is a sphere. Imagine a line running from the equator to the center of the Earth, and then another line running from the center of the Earth to the North or South Pole. These two lines make a 90-degree angle. All latitudes in each hemisphere can be represented by drawing a third line somewhere between them. So the equator would have 0 degrees latitude, and the North Pole would have 90 degrees north latitude, and a location halfway between the North Pole and the equator would lie at 45 degrees north. Same thing for the southern hemisphere, except you'd call it degrees south. For more precision, each degree of the Earth's surface is divided evenly into 60 minutes, and each minute is divided into 60 seconds. If you need to get even more specific, you can just add decimals to your seconds. Alternately, you can write the whole coordinate in decimal notation. To do this, you have to convert minutes and seconds, which are base 60, into our regular base 10 counting system by dividing each unit by 60 and then summing them up. The results sometimes look counterintuitive, but if you're skeptical, you can pause the video and check out the math. Lines of longitude, also called meridians, run north-south and are used to measure position along the east-west axis. While the lines of latitude run parallel to each other, meridians converge at the poles and spread farthest apart at the equator, like the segments of an orange. Longitude is also measured in degrees, but its 0-degree line is known as the prime meridian, and it runs from the North Pole to the South Pole through Greenwich, England. So, if the prime meridian is 0 degrees, the opposite side of the Earth is 180 degrees, and lines in between are expressed as degrees east or degrees west, between 0 and 180. Since the lines of latitude are parallel, each degree covers about the same distance the world over, roughly 111 kilometers. But because meridians converge at the poles, the distance covered in each degree of longitude varies hugely depending on your latitude. At 20 degrees north, which is about the latitude of Cuba and Hawaii, 1 degree of longitude is approximately 104 kilometers. At 80 degrees north, the latitude of Svalbard and northern Greenland, it's only about 19 kilometers. So, let's say I wanted to go dig up a stash of hot loot from some coordinates I found written in a mysterious note. Even without looking at a map, we can start to make a guess where this would be. Since it's 43 degrees north, it's almost halfway between the equator and the North Pole, again halfway being 45 degrees. And since it's 89 degrees west, it's almost halfway west between the prime meridian and the opposite side of the globe, halfway being half of 180 degrees or 90 degrees. Based on this alone, you can guess it's probably somewhere in North America. But if we use a map or a digital tool like Google Earth, we can zoom in and see these coordinates lead us to the U.S. National Mustard Museum in Middleton, Wisconsin? Huh. Well, what's the weirdest landmark you've ever found on Google Earth? Paste the coordinates in the comments so everybody can check it out. If you like this video, hit that thumbs up button and subscribe for more. And as always, for answers to all kinds of questions like this, head over to howstuffworks.com.
All right, let's go back to our lesson, which is this way. Next, so we need to learn some words, right? So location, well, we're going to learn the term absolute. Well, what does absolute mean? So go ahead and talk about that, just briefly put it in the chat. What does absolute mean? Okay, what does relative mean? You can do that one too. Compare the two. What do they mean? Well, how are they different? All right, so the absolute is the exact location on the map. Okay, absolute means like exact. Let's give you some examples. So we'll play a little game. So where am I? Latitude 38 degrees, 53 minutes, 51.6336 seconds north, 77 degrees, 2 minutes, 11.508 seconds west. Elevation is 18.036. I don't know what that is. It could be feet or meters or yards. I don't know. And then time zone is America. It's the same time zone as New York City. Okay, there's the address. 1600 Pennsylvania Avenue, Northwest, Washington, D.C. 20500, USA. Type your guesses in the chat now. Okay, it's the White House. Yay. Okay, so that's actually would be, we can see the latitude, longitude. That is an absolute location. That's what we call it. Okay, you need to memorize that because we're going to use this all year. Absolute location. Next, where am I? 40 degrees, 46 minutes, 58.314 seconds north. 73 degrees, 57 minutes, 55.278 seconds west. Elevation 34.392, so a little bit higher than Washington, D.C. Actually, Washington, D.C. is famous because it has a river running right through it. So, and then same time zone, New York. And the address, oh, I didn't mean to have that on there. But anyway, it's in New York City, okay? It's Central Park, okay? So that's a famous park in the middle of New York City. So you can see here that the whole city surrounds this park. So that right here, the latitude and longitude, those are gonna be exactly where on the whole Earth, this is the only thing that's there is Central Park, okay? That's how you find where Central Park is on the Earth. All right, next thing is relative, okay? So this is a location that's described compared to something else, to another location. So for example, we could say the White House is in central Washington, D.C. We could say the Central Park is in central New York. And then we could say Roy J. Smith Middle School is near Walmart in Southern Killeen, okay? All right, so yeah, you need to know your north, south, east, west. And in my classroom, we have those posted. But it would be a good idea, if you like history especially, to ask your mom or dad or whoever to help you and maybe print out some paper, 4 pieces of paper, and find the north, south, east, west parts of your house. So you can start to memorize where those are. Okay, next, more vocabulary. So latitude. And the way I remember this is it's for latitude, fat, so you go wide, left to right, okay? So those are the lines that go around the Earth. So we can look back at right here. We zoom out, let's go back to actually, let's go to the Earth. We zoom out, well, I don't know which will be better. We'll just use this one. So there are lines along the Earth, okay? And those are the latitudes, like this one here, okay? It goes left to right, latitude. All right, next one, longitude. It's long, it goes from top to bottom. So we have lines that go north to south, and they're not written on this map. If you look at the maps in the book or maps in our room, in the classroom, then you would see that there are lines that go north to south. So you need to memorize these two. Latitude, you can remember fat, wide, left to right, or longitude, long, it's top to bottom. It's like it's tall, okay? It's the opposite of latitude. That's how I remember it. All right, and now welcome to the center of the Earth. Wait, is there a center of the Earth? Where is it? Where is the center of the Earth? Can we even go there? Well, no human has ever been to the center of the Earth yet, but we can say where we start counting the latitude and longitude, okay? So kind of talked about this briefly, but we're looking at 0 degrees north, 0 degrees east, or 0 degrees south, 0 degrees west. It's actually gonna be right around in here, okay? Oops, okay, so I thought I had a picture of it, but it's right here. So this right here, this is the equator, okay? And if we zoom in, well, okay, so we lost it. But it's right around in here, would be the 0 point. So everything in the whole world is centered in terms of latitude and longitude around this point right here. So the equator, which is this line in the middle of the Earth, the latitude, okay, that's also where the sun is the hottest. There's all of these countries along here, okay? That's the equator. And then we have the prime meridian is another word for the line that goes through the UK right here, okay? Next one, international date line is on the opposite side. So we can look at it on this side here. And it's kind of crooked, you notice that? So it's not a real line. It's not a straight line in a way. But if you look at this, like for example, Hawaii is on the far western side of the line, okay? So if you look at the Earth, it's all the way over here. So it's like at the end of time, okay? And then over here, we have New Zealand, which is at the beginning of time. It's all the way at the eastern side of the earth. So what that means is that like on a Monday, for example, the sun is going to rise first pretty much in New Zealand, actually probably over here, okay? And that means that the Monday will begin first around this part of the world. And then people will start to wake up on Monday morning, a little bit at a time, and go towards the west. And then, America starts to wake up. We're kind of last in line to wake up for the Monday or whatever day. And then Hawaii all the way over here, okay? And then when Hawaii wakes up, the next person to wake up is New Zealand again, and they wake up on Tuesday, okay? So if you're flying an airplane, you fly from Hawaii to Tokyo, you're gonna leave on Monday morning, and you're gonna fly this way, and you're gonna arrive on Tuesday afternoon. Isn't that weird? Leaving on Monday, you're not gonna get there till Tuesday, and it only takes you like, I don't know, like 6 hours. It's kind of funny, huh? Somehow you gained a lot more than 6 hours when you crossed the line. So that's all made up, okay? People made up this line to make things easier for our world. But the discussion on time is for another day. You can ask questions if you'd like later, okay? So international date line is another word we need to know. All right. What are some important tools that you can use to picture the world? Let's talk about that or think about that briefly. Maybe put it in the chat. What are some important tools you can use to picture the world? Well, the answer is maps. Okay, that's all we have for today. So this map right here can tell us a lot about the world, and we're going to learn a lot more about maps over the next few days. Okay, you can play around on Google Earth and learn a lot about the world. You can learn a lot about, you can even see here how it changes from like a dark green where we have lots of mountains and lots of rain into a more lighter green where there's more grass, right? And then we go out here and it gets drier and drier. We have our mountains up in here where there's less rain. So you can see a lot about a world, right? You can see that there's gonna be a lot less water, a lot harder to live over here in Arizona compared to in Alabama, right here, okay? So thanks for watching, and we're gonna go back to your teacher in your Zoom class. Or asynchronous, you need to take a look at Schoology for the next activity for the end of the social studies day. Thanks, bye.